All right, we're starting activity 2 on page 420. We'll be going to 423. Pretty much just working on activity 2. Okay, so it says for this, in this activity, we'll describe a function or the intervals of a function by analyzing the values of the function. So our situation here, it says Saturday morning, Erica walked for 30 minutes at a steady rate. Let's go and highlight that. From her house to a park that's 3 miles away. When she arrived, she played basketball for an hour. And then she caught a ride home with Kendall. She traveled at a constant speed from the park to Erica's house and arrived in 12 minutes. So let's go and answer some questions and represent this scenario. All right. So for number 1, it says describe variables or define variables for the time since Erica left home in minutes and for her distance from home in miles. We're going to let t, we're going to let t equal the time in minutes. Since Erica left home, and d will represent the distance from home. I'll just put dist from home. All right, and that is in terms of miles. So for number 2, it says sketch a graph for Erica's morning. We have our x-axis as time, y-axis in distance from home. We're going to have something that looks vaguely like this. We're going to have a line going up, a line that's kind of plateauing, and a line that's coming back down. All right. So this first part, I'll just call this part A, right? This is her walking to the park at a steady rate for 30 minutes. This part B is her at the park for an hour. And then part C is her going home. This line is steeper than the original line because, right, a car is going to go faster than walking. But let's go ahead and talk about these rates for number 3. Determine the rate at which Erica walked to the park and the rate at which she and Kendall drove home. Express the rates in miles per minute. So for Erica, let's put this in red or black. Walked, we'll just put walk. So this was 3 miles, and that was in 30 minutes. So if you wanted to, you could divide both of them by 3. They're both divisible by 3. So this is 3 divided by 3. But we should have it per minute. So we're actually going to divide both by 30. So we'll have 1 minute here. All right, so we're dividing by 30. If you divide 3 by 30, you're going to get a decimal. It'll be 0.1. So 1/10 of a mile every minute. Okay. All right, and then for the drive home, we'll put drive. That was, right, also 3 miles, but in this case it was 12 minutes. So if we want it per minute, we're going to have to divide by 12. So we still get 1 minute at the bottom. But if you divide 3 by 12, you'll get, or that's a quarter, so 0.25. So a quarter of a mile, this should be mi. Quarter of a mile every 1 minute. All right, moving on to the next part on page 421. So it says, determine the domain time and range distance from home for each part of Erica's morning. So walking, playing basketball at the park, and then coming back home. Okay, so we'll get to part 5, which is writing an equation, but if this is represented by t, let's go ahead and talk about this. So from 0 to 30 minutes, that was walking to the park. So how do we write that? That is 0 less than or equal to t less than or equal to 30. This just means that the time is from 0 to 30 minutes, and that's all walking to the park. For this part, I'm actually going to go to the range. That is distance in miles. So this park is All right, three. So she walked from 0 to 3 miles. So how do we write that? So it's 0 less or equal to d, not t, less than or equal to 3. So the distance is from 0 miles all the way to 3 miles. Okay. Now let's go to the part where she was spending the majority of her time, which was at the park. And that was, she was there from 30 minutes. She played for an hour, so 60 minutes. If you add that, you're going to get 90. So t is less than or equal to 90. So from 30 minutes to 90 minutes in this scenario, she's at the park, which is exactly 3 miles. So in this case, we don't have an interval, we just have an equation. The distance is equal to 3, and she's staying at 3 miles away from her home at the park. And then now she's getting a ride, so she's coming back home. So at the 90-minute mark, she's coming back home. And that is, it took her 12 minutes. So if you add 90 and 12, you'll get that t is less than or equal to 90 plus 12 is 102. So from 90 minutes to 102 minutes, we are coming back home. So this is exactly the same, 0 to 3. Okay, so now let's determine an equation. So remember, in an equation, if it's proportional, right, it looks like this, y equal to mx. And if it's not proportional, it's y equal to mx plus b. Okay, but we have other variables, right? We talked about that we have t and d. So for the equation for A, Erica's distance from home as she walks to the park, we said that she went at a rate of, right, a tenth of a, oops, I should not have minute, it should have okay. A tenth of a mile every 1 minute. So that's 0.1. That's how fast she moves. So the distance is 0.1 every minute, or t. Right. So if she's walking, let's say 20 minutes, plug in 20 in for t and multiply it by 0.1. The equation for Erica's distance from home while she's playing basketball, we already wrote it over here. It's exactly 3. The distance is equal to 3. So she's not at a rate because she's at one place, that being the park. Okay. And then for C, Erica's distance from home as she rode home from the park. So with that, right, she begins at a certain rate and she's decreasing at a certain rate. So this is, right, a quarter. We're going to represent a quarter though as 1/4 instead of 0.25. So for this is d equal to, where she begins is 3. The slope is the distance that we're going home is decreasing, it's getting smaller by a quarter, right, every minute that we have. But for this, we do have to put in parentheses, we do have to subtract 90 because this does not include, right, the 90 minutes of her walking to the park or playing at the park. So that's why we have this. If you were to distribute this and then also combine like terms here, you would get I'm just going to simplify it. This would be 51 over 2 minus 1/4 t. This is after multiplying a fourth times 90 and then combining that with the 3, the other constant. So that we'll just keep. But let's go ahead and describe for number 6. Describe what happens to Erica's distance from home in each part of her morning as time increases. So time is always going to increase, right? Time does not decrease, right, as the day goes on. So for this part, number 6, we're going to say as the time increases, I'll put INC. Walking to the park, does her distance increase? Does it decrease? Or does it stay the same? We're going to say that the distance from home increases. Right, the distance from her to the park decreases because she's getting closer to it, but this is comparing it from home. Right, everything is comparing it from home. as she's playing basketball, so we're going to say as time increases again. The distance, she's only at the park playing basketball, so the distance from home is constant. Right, it's just exactly 3 miles away. And then her ride back home, as the time increases, comma, right, she's getting closer to home, so that distance is less. So the distance from home decreases. Okay, now we actually use these vocabulary terms, but we're going to properly define them on the next page on 422. So let's go and look at that. So it reads, as you describe a function by analyzing the values of the function. When both values of a function increase together, the function is an increasing function. So pretty much anything with like a positive slope. And then when the y value of a function does not change or remains constant, the function is a constant function. So that is a zero slope, or not increasing nor decreasing. And when the value of the dependent variable decreases as the independent variable increases, the function is a decreasing function. So that looks like a negative slope. Okay, right, as we go to the right, we're going down. But let's look at number 7. So we already drew this before, which was just drawing like a rough graph of her trip. But we're gonna write for number 7, what are the domain and range for Erica's morning in this problem? So the domain is the time that was spent in this situation. So we're gonna put domain. And the total domain, I know we put certain intervals, but that is from 0 minutes all the way to the most amount of time in the situation, which is 102 minutes. And then the range in this situation is the lowest amount of distance and the biggest amount of distance that she was from her home. That is 0 is less than or equal to D, which is less than or equal to 3, right? The distance from the park shouldn't go any further than that. But anyways, that's pretty much it. So just kind of combining all the different parts that we have. And then B, does the graph of Erica's morning represent a function? So does this pass the vertical line test? If you remember, we take any vertical line. It looks like it's vertical. We take this, right? This crosses once. Right, this crosses the graph once, this crosses the graph once, this crosses the graph once. You're not going to find any place where it crosses it more than once, so this is a function. So let's put yes. Let's put yes, this does represent a function. I'll just put it's a function. And we'll put just another sentence here, is that Erica is only one distance, one distance away, or I should say distance from home away at any given time. Right, if she wasn't, then she would be at 2 places at once, which we talked about how that's not a function. But let's go and put everything together that we have into this table. So we're going to combine all the different problems that we've done just so that this information is organized. So we're going to start with the first part, walking to the park. The behavior is that it was increasing. The equation of that was D equal to 0.1 times T. And the domain of this was 0 less than or equal to t, which is less than or equal to 30, right, for 30 minutes. Playing basketball, right, the behavior was that it was constant. The equation for that was just d equal to 3, did not change, it's only 3 miles away. And she played there for an hour, so that was from 30 minutes all the way to 90 minutes. And then riding home, right, the distance from home is decreasing. You're getting closer to it. The equation, a little bit more complex equation, was negative 1/4 t plus 51 halves. So that took a lot of effort to figure that out. But from 90 minutes to 12 minutes after that, which is 102 minutes, right, that story then concluded. Okay. Anyways, we have everything there. So far, good work. Let's get to our last page here, which is we're looking at this situation, but let's actually get to some vocabulary terms first. So this is when you describe the intervals of a function by analyzing what happens at a specific independent value. When a function increases for some values of the independent variable, it has an interval of increase. So that's what I was talking about. It's just a positive slope. When the function decreases for some values of the independent variable, it has an interval of decrease. And when the function is constant for some values of the independent variable, it has a constant value. So we're going to look at the graph below and just find the parts that it increase, decrease, and is constant. So we're going to write that below. Actually, let's do that. Let's put that right. Let's put increasing. I'm going to need to space this out. Let's put decreasing right here. And I'll put constant. We're going to have to put it over here because we don't have too much room. I'm going to highlight these in different colors here. Let's put this one in red. Put this one in blue. So if you have a highlighter, you're welcome to color code, or you're welcome to use the color pencils that we have in the classroom. Okay, so let's highlight the parts that are increasing. So the parts that are increasing, this part is increasing, and this part is increasing. So you know what, let's start there, and then we'll move on to decreasing. Okay, so whenever we have a line segment, I like to use the endpoints here, so here and here. You can also put this in red. And let's find the domain. So we're looking at the domain for each part of this. So this part right here, that is from, this looks like 2.5 and this looks like 4.5. So these are the values for x. So we'll write this as 2.5 less than or equal to x less than or equal to 4.5. Okay. And then let's also do the other part. So we're going to go to the other red part. So right here, let's drop a vertical line. That is at 7. And here, this apex or local maximum, that looks like right here, that looks like that's 8.5. Okay, so 7 to 8.5. So we'll start with 7, less than or equal to x, less than or equal to 8.5. All right, good. So those were the increasing portions. So I'm going to get rid of these lines just so it's not super cluttered for the next part, which is decreasing. Okay, so decreasing we're putting in blue. So that is this part. Anything else? Yep, this last part right here. Okay. So it's going to identify that part. So from here, or this is the very beginning, so that is at 0. And this is also where we left off on increasing, or we started on increasing, which is 2.5. So this is from 0 to 2.5. We write that as 0, less than or equal to x, less than or equal to 2.5. And then this other portion, we'll start at this, again, the apex, which was 8.5. And here, not too hard to find, it's already on the x-axis, that's at 10. So 8.5 to 10, that's all decreasing. So 8.5 less than or equal to x, less than or equal to 10. right? It's always going to be less than or equal to, because what we're saying is the x value is greater than 8.5, but it's less than 10, also including those values. Okay, so we almost have everything accounted for, but we do have to do the green portion, which is constant. And there's only one constant part. I'll put this in green. That is this part right here. All right, so let's find those regions. Okay. This is at 4.5, and this is at 7. So from 4.5 to 7, we can think about this in terms of time. Maybe 4.5 hours to 7 hours, where we're not going anywhere. We're just staying in the same place. So that is 4.5 is less than or equal to x, and that's less than or equal to 7. Okay. All right, a lot of annotations that we had to rewrite, but overall, right, we know how to find the varying parts. It's just a matter of looking at where they are on the x-axis. I draw lines, but maybe you can just kind of compare and see where it lines up on the x-axis. But let's go ahead and answer number 9 in relation to this. Explain how the behavior of each part of the function relates to the slope for that part of the function. So, right, we know, actually I'll put this in black, is that the increasing parts have positive slopes. The constant parts that they have, right, it's horizontal lines, but those are slopes of 0 or 0 slopes. And then the last part, decreasing parts or decreasing intervals, right, they have negative slopes. Negative slopes, whoops. All right. Anyways, we'll get to activity 3 on the next page, on the next day, but we're just only working on activity 2 for now.